Recording in progress.
Awesome. Okay, so let's talk about the test. So the test has been written. I'm looking in front of my phone right now.
You should show it.
Oh,
You should show us it.
thanks. Well, I'll show you the outline. Okay, so I know, right? Okay, but the outline, I'm not going to tell you like the order of the questions, but I'll tell you what to expect. Like, okay, for the first one, given real or imaginary roots, write a polynomial equation. Yes, I'm going to ask that. Good example of that. So given real or imaginary roots, write a polynomial equation. Good example of that would be, and this is what 8b. Okay, so I'm going to label it on the problem sets, on the review problem set. If I give you the roots, find the equation, that would be like, ooh, yeah, this right here.
Is that pretty close to the test question?
Yes, it is. I'm looking at it right now. Where, yeah, I give you the roots, you give me the equation that goes with it. So we'll talk about that later. But yeah, that's been on the homework anyway. Problems like that. Actually, there's a few problems like that on the homework. I did a bunch of the answer keys this morning and afternoon. So yeah, that's the first problem. Right. So 8b, well, not the first actual question, but that's just the first thing listed there. So given real imaginary roots, write the equation. Actually, let's talk about how did I do part B, guys? What do you guys think? What would I do? And this is all being recorded, by the way, so you can watch this recording. Let's say you have those as your solutions. How would I write my equation that comes from? What would I say? You could do a couple things. You could say x minus equals each of those, right? You could do that. I wouldn't recommend this because here's what's going to happen. If you do this and then want in standard form, what do you have to do with all that junk?
Well,
and that's a lot to FOIL. I wouldn't recommend that. That's kind of crazy. What CPM suggests, which I think they're on the right track, is if you think about it, wouldn't this be a true statement? If you consolidate both answers, can you consolidate both of them like that? Then what do I do next? Do you guys remember? What do I do about the 2? Good. Okay, so that's triggering something. It's good. Then what do I do after that?
what?
Yeah, square both sides. Yes, good. It's coming back. And what's the square of positive or negative root 3? It's still going to be, whether it's positive or negative, what's the right
Why
side?
wouldn't the root 3? Why wouldn't the root go away if you square it? Oh, you just did.
No, I haven't written it yet. What's the square of that?
Positive.
Great. And what's the left side? X squared minus 4x plus 4. And then lastly, last step, x squared minus 4x plus 1 equals 0. What are you doing in this problem? What you're doing is telling me the equation is stable. That's all. You're working backwards. It's back solving. It's called back solving for a reason. You're back solving, going backwards. So if I give you this problem, which you've done many times, you get me this as an answer, right? So now I'm just asking the reverse. I give you the answer, give me the question. That's what that first item is saying. I will make a delta math. I've not done it yet. Maybe while you guys are working, I can make a delta math, but I'll make a delta math so you can practice the skill. So that's one question. Guaranteed. All right. Next up. Okay, this is where you're gonna put yourself in my shoes. What am I thinking when I write this test? Look at 8G. Operation of the imaginary numbers. Given any complex number, write it in standard form. Okay, we've done this already. Let's go back to our old test. It will be, yes, but hold on a sec. Actually, no, it's not. No. So here's our old test, right? So unit 5. Oh gosh, you had 3 versions. That's crazy. Okay, here's also okay. So we've done this already, right? Yeah. Do you guys remember these problems, right? You guys did great with this. Okay. I've already asked that. Yeah.
Not understand the 2 to the I when 125.
Don't worry about it, because let's look at the review guide. I've already asked that. Well, to answer your question, because for the sake of the final exam, you have to do I-125 I-5, which is I-130, right? Because you combine the exponents. Add. Okay. Then what you do is you do 130 divided by 4. Because they go in cycles of 4. I1, I2, I3, I4. It's an even number, but remainder of 2. Because 30 is not a multiple of 4. So it's like, explain again. Yeah. So you combine the exponents. So it becomes I-130. And then you divide by 4, which has a remainder of 2. Because 30 divided by 4 is 7th remainder of 2. Right? Because 4 goes into 37 times. It's 4 times 7, 28, remainder of 2. If it's remainder of 2, it's like I squared. Well, what's I squared? There you go. That's your answer. Well, then times, of course, 10. Yeah. But put yourself in my shoes. I've already tested you on something like this. Look at the review guide, okay? You see these problems here. Great. But am I going to ask this on the test? Do you think I would ask this question? Am I already asked it last test? No, I'm not asking. Plus, is that too easy? Yeah, it's too easy.
No.
What do you think I'm going to ask? If you keep scrolling. Okay. Look at this one. Have I asked this question yet?
Yeah.
I've not asked this question yet. This is more recent. Make sure you can do this question. That's 8G. That's 8G. And I'm going to put a lot of Desmos problems like this too. Not Desmos, sorry. Delta math. Use my words. I'll put delta math problems like this. Again, I haven't made a delta math yet. I'll do what you guys are doing work today. Or I have a free period coming up. I'll do it then. So, okay, that's the second question. So expect that. Okay, so now I've told you 2 questions. Imaginary roots or real roots, find the equation. Imagine numbers, work it out. Okay. The polydoku, the table. I'm going to ask you to divide 2 polynomials, right? So, yeah.
Will you use synthetic for that? 8/8.
You can't, I'll accept if you do synthetic. I will accept. I'm looking at the test right now. Yeah, you can totally do. So good examples of that. That's just more of a skill, by the way. So it's kind of hard to say what question that could look like. But if I go through the review guide, where do we see division? Okay. First question is not about division at all. Second one's not about division. Third one's not about division. Fourth one's not about division. Fifth one, no. Sixth one, no. Seventh one, no. There we go. 8H. Make sure you can do this problem. Now, yes, Nathan, you can do synthetic division if you like. I will totally accept that. You do long division, which I don't think I really spent any time doing. I'm not going to force you to do long division because I haven't really emphasized it. And plus, you'll see again pre-cal. But yeah, I will ask you to divide. So make sure you can do that question. All right, so that's something I will ask. Elsewhere where you might need to use that skill. That one's kind of easy. You just have to look at what factors of 10 are. That's not really dividing. Yeah. So anyway, that's that for that one. Okay. Next up. Given a graph, 1 factor of 1, 0, find everything else. Okay, so 8i. Where is that going to be? Okay. So if I give you something about it, give me everything else. I give you something about it, give me everything else. I don't see that here. So that's going to be more in the homework. So let me talk about the homework really fast. So this would be I don't have an answer key for you. I'll make one. Let me go back to the homeworks. Let's go to 8, 9. Let's go to 8, 8. So no, I just did this today. Bingo. There we go. That is like a test question. where I'm gonna give you a graph or tell you a zero that it has. And you have to tell me all the other x-intercepts. Okay. So that would be like, too much stuff open here. Close that. Close that. Yeah, that'd be like 8i, given a factor or 0. So this is on the homework. So this is a homework that was due sometime last week. This is 8.8 homework. The solution key is right up in Schoology. You see how it bounces at 3? So divide by x minus 3 and do it twice. There's another one just like it right there. Where is this cross the x-axis, guys?
Yeah.
So divide by x minus 2. Break it down afterwards. That's what I'll ask as well. Because that's kind of the essence of this unit. Okay, so that's 8i. Okay, factoring. Yes, I will ask you to factor. And using division techniques, this would be like HA. So these problems right here. And that's kind of a review portion in a way, because we had this before. So I'll ask you that. By the way, I am going to give you this formula. You guys know this formula. What's this formula?
Quadratic.
Quadratic formula, right? I will give you that formula. Yes, you'll have to use it. Also, I'll give you this formula too. Remember, say a cube minus b cubed.
No, we're not.
A cubed minus b cubed equals, remember I showed you this formula? Equals something like that. I'll give that to you as well.
And the positive one.
Yes, I'll give you both.
This is off topic, but what is a
Sure.
polydotee?
The table,
Dividing.
the table, division. No, it's not off topic at all. You're on topic.
We don't have.
You're just you're going against grain. You're doing something else. Yeah, that's fine. I like how you're against grain. So I'll give you those formulas. Don't worry. Also the a cube plus b cube one. I'll give that to you as well. Okay, so that's 8 J. Okay, some of the more recent stuff, given a rational function, describe the end behavior, blah blah blah. That's going to be near the end of this packet. So that's 8 K. So this stuff here, we're going to talk more about this today. This is 8K, this entire page. So it's more recent stuff. So they have that on the test.
You have to draw like those sine graphs.
You don't have to know. Complex fractions we talked about last week. I don't see that here. I think it's on the homework.
Can you do 8,185?
Sure. This one here,
Cause I like started.
the division.
No, cause I did it. I'm on the, what's it called? The quadratic thing now. And I was
What do you get for your quadratic?
7 plus and minus square root of negative 23.
Okay, so that's where you would use a calculator to get the decimal equivalent to those.
So
And
they
you just,
have
you
to
just
be
get close
decimal?
enough. But then you have a calculator where you can
Is
just,
there a calc and a non-calc section?
Can't you not square root a negative?
you get a negative. Oh, is it negative underneath the radical? Is it negative underneath the radical?
What's that mean?
No, the radical part, the square root part. Is there a negative underneath the square root?
No, there's a square.
That's what I'm asking. Is there a negative? There's a negative underneath it.
Yeah.
Yeah, then you won't have x-intercepts there. You just won't touch. You won't have one
Who's the
x-intercept.
match?
Okay, exact, correct, right. So you can neglect that. Yeah. Anyhow, moving right along. Simplify complex fractions on the most recent homework. So this right here, these problems is from the 810 homework. That's going to be like 8L. Again, I'll put this all. Delta math, as you know, is really my go-to. I will put each of these items try in this particular order, so you know exactly. Okay, I gotta do this. Like these are all things I gotta do, right? So I'm definitely gonna ask that. And yes, we're asking that. Okay. Then there's some stuff in the last test. So to help you guys get some points back, not necessarily all these times, but these skills. Discriminant we talked about, term number of real complex zeros, finding the factors, sketching, these are all stuff from before. So and you have, standard problems you could look at. I'll make sure I put this in Delta Math as well. So, and I think this is covered in the review packets. Maybe, not really.
When you got like those like one-on-one meetings, we do that.
That'll be during the review week next week. Yeah. Anyhow, so you have that. So that's essentially the test. So that's how the test is going to look. So this is your checklist. Again, I will do Delta Math. So you guys have each of these items you can practice. If you feel like you mastered each of these, then you're good. Okay. Homework review really quickly. Here it is. All the answers are up. I'll leave it to you guys to check your work. But any questions, any burning questions you want to ask about the homework that you tried over the weekend, you're stuck, that you want to ask about?
No.
No? We're good? Okay. So let's do a short lesson, and then the rest of the class you guys can work on homework or start doing review. So let's get to the lesson. So let me leave that open. I'm just going to gloss over these. So I'm not going to do all this because we decided that we're not going to cut some things out. And also kind of the homework too, because some of the homework I don't want to assign. Oh, the quiz. You guys want to know the answers for the quiz?
Yeah.
You already know the answers? Okay, here we go. Here is a quiz. Sine 240 degrees. What coordinate are you looking at, y or x? Good. You want the y coordinate. At 240, the y coordinate should be negative √3/2. Okay, that's good. Okay. Cosine negative pi is actually at 180. It's halfway through. And its x coordinate, -1. I like it. All right. Tan -60, also negative angle, but it's going to be the fourth quadrant. So it's going to look like this. Oh, bless you. And it's going to be the y over x. I want y over x here. So this is x coordinates. That's y over x. It's definitely going to be a negative answer. And do you get -√3? Good. Because you're doing -√3/2 over +1/2.
Yeah.
Good. If you left it like this, I would accept it full credit too. Both like that. Okay. Then for that's what I just said. Oh, that's fine too. Old school. That's all good. Yeah. Okay. Okay. An angle that has a negative cosine, so x is negative and y is positive. You're in Q2. Anything in Q2 would have worked. Anything in Q2 would have worked. Tangent value of 1. That's going to be in two places.
It's gonna be in first.
80
and third,
degrees.
but
First and third, yes.
I have to say first and fourth.
Oh,
so I
sorry.
mix it up.
45 and 225.
Yeah, I think that's
Okay. And then lastly, part C, this is the x coordinate. So cosine of 150 is negative 1/2. No, -√3/2, my bad. So where would that happen? There's two places where it could happen. You could do a 4π/3
Or 5/3.
or 5π. I would accept either. I didn't ask for both. I just accept either one since I asked for both. So, okay, cool. Good. Okay. So that's going to be like final
Did you
exam
go up? I
questions.
I didn't see the first question. What was the answer?
It's gonna mess you and put some weird numbers, but I'll be straight with you. -√3/2, -1,
Yeah.
and √3. -√3. Okay. Cool. All right. Okay. All right, guys. We're doing great. Let's wrap up the notes for very short notes today. Let's look at number 1. Okay. Determine when the denominator is 0, what happens, and then also, yeah. Yeah. So we're gonna do some very simple stuff today, and then you guys will just do some work. All right. So the last page of the notes, I think it's page John, can you tell me what page that's gonna be?
Page
30, 29.
29.
29 and 30. And that's it. After 29 and 30, we're done. And this is actually last bit of new material for the rest of the year. You won't see any new math unless you do some fun math stuff for the summer or
Oh, yeah.
yeah, exactly. Or you or till August, right? So anyway, this is the last bit of new math for the year. Okay. So vertical asymptotes, guys. You guys should know this. Hopefully you guys remember. How do you find a vertical asymptote?
Plug in 0.
No.
So is
It is going to be a vertical line, but from the equation, how do you tell?
Oh, plus whatever, plus K. Yeah.
It's when the denominator is 0. It's when the denominator is 0. So it's H, not K. It's H. It's
Okay.
going to be X equals H from the general equation right there. It's going to be X equals H. It's when the denominator equals 0. That's all it ever is. Okay. There are some variations. You'll learn that in pre-cal. I'm not going to get into the messiness of vertical asymptotes. I'm going to keep it very straightforward with you guys. It's whatever makes the bottom 0. That's it. So let's look at part A. I'm going to set this equal to 0. Part B, I'm going to set this equal to 0. Part C, I'm going to set this equal to 0. And you're going to solve for each case. Now, there is going to be something called a hole. And it won't be a vertical asymptote. I'm not going to discuss that in this class. You will do that next year in pre-calculus. We're going to keep things very straightforward. For now, where it makes the bottom 0, assume it's going to be vertical asymptote. That won't always be true. So don't come back to me like in a few months. Oh, Mr. You said so. No, I did give you a disclaimer. But for now, for this class, whatever makes bottom 0, we'll call it vertical asymptote. So how would I solve part A?
X.
Take out an x squared. What's left behind when we take out x squared?
X minus 1.
What makes those 0? Either x is or 0.
Wait, what?
yeah, sense.
Because if you
X
plug in,
squared would be 0, and then X minus
because if you plug in 0 to the bottom, you get 0. 0 squared minus 0 cubed, or 0 cubed minus 0 squared is 0. Okay, what can you factor out from part B? X again. What's left behind?
squared minus X. Wait. Yeah.
Minus 12.
Okay, let's keep going.
What are we doing with you? Why are we doing that? Negative 3.
Yes, x equals 0. X equals 4. Or x equals -3, correct.
So how do you know which one it is?
It's all 3. You have 3 vertical asymptotes.
Oh.
And then lastly for this one, what can you pull out?
Negative X.
Yeah, I do negative x, just keep everything positive inside. And what's gonna make that 0?
12.
Or
0.
Negative.
actually -12.
What?
Yeah, negative.
Oh, yeah.
So what this means, what I need to see is you need to draw these dashed lines. Like I'm not gonna ask you to graph these because these are really crazy.
You don't have to do
graphs.
0, right?
But I'm just gonna ask me, hey, where are the vertical asymptotes? So the vertical asymptotes would make bottom 0. Okay. And I'll make sure you guys have practice on Desmos. And I believe we do ask about that kind of. Yeah, we do. We do. Okay. So again, vertical asymptotes, what makes the bottom 0? It's a boundary we don't cross because it's undefined. And that's what I'm looking at. And if you have something like a over x minus h plus k, then whatever h is, that's your vertical asymptote. Or if you have something a little more complex like these here, whatever makes the bottom 0. Again, I'm not going to make you graph these. That's in pre-calculus. I'm not going to make a graph like A, B, or C here because that's too much. We're not ready for that. That's next year. But do no vertical asymptotes. Okay. Next up, horizontal asymptotes. Okay. We talk about vertical. Now let's talk about horizontal asymptotes. We're going to ask this as well. Horizontal asymptotes. This is a little tricky. What you want to do is simply compare the highest exponents for both numerator and denominator. Okay, that's all we're doing. I want the highest exponent for both numerator and denominator. We're going to compare them. Okay, switch colors for a bit of contrast. Let's go to dark green. Okay, let's look at part D. What's my highest exponent in part D?
Cube.
X cubed. What's my highest exponent on the bottom?
Squared.
Okay, let's do this for the other two. What's the highest exponent for part E?
Cubed.
What's the highest exponent for the bottom? Part F, highest exponent.
Squared.
And okay. What you're gonna do is reduce each of these. I know you guys can reduce. What does that reduce to?
X.
What does it reduce to?
5.
It's reduced to.
Negative X.
Great. What you just did is actually a calculus principle. It's called the end behavior model.
So pretty much we're in calculus.
You are. In some ways, yeah. You're moving to pre-calculus next year. All right. So that's a great class too. Actually, I kind of enjoy it a little more than calculus. All right. Now here's the deal. This behaves like y equals x. This graph will behave like y equals x at the ends of the graph. At the far reaching ends, far left and far right. So if x is approaching infinity, think about it. If x is infinity, right? What's this going to be if this is infinity? If I plug a large number, is this large?
Yeah.
Okay. If I plug in negative infinity, is that negative infinity? Yep. So what we're going to say is that this is going to be infinity. And that's going to be negative infinity. That's called the end behavior. If you were to graph this in Desmos, I won't do it just in interest of time, but just trust me, if I were to graph this in Desmos, the left arrow is going to point down. Right arrow is going to point up. Because it behaves like the highest exponents. The highest exponents dominate all the other terms. Okay. For E, take a look at part E. By doing this comparison, what did this reduce to when I compare the highest exponent of both top and bottom? 5, right? So what's going to happen is that if x goes forever to the left or forever to the right, and actually the more thing I should show you guys in Desmos, so I'm going to show you really fast. Desmos. Okay, 5x cubed minus x squared. Take a sweet little time. Y equals division 5x cubed minus, was it x squared, guys? Okay, then down below x cubed. So plus x squared minus 12. Okay, that is a strange looking graph. Again, I'm not going to make you do this graph on the test. We're not ready for that yet. Look at the far left and far right. What is this? I know it's toy discussing, but it's great when you finally can figure it out. Okay, what far left, the far left, guys.
Oh,
What's
far left. 5.
Five.
I'll take reference.
Okay, yeah. If you're super liberal. Okay, if you're Nancy Pelosi.
Oh, I get it.
If you're Donald Trump or JD Vance.
Ah.
There we go. Okay. Fox News or CNN.
Got it.
But here's the thing: are they going to the same place? No. Well, actually, they are. They're both going towards 5. This is how math brings everyone together. Now we're bipartisan. Yeah, okay. I'll stop the politics joke. I love politics, by the way. Politics is fun. Anyway, sorry. What does it look like? Oh, maybe. Anyway, Okay, so far left, far right. I like the political reference, Nathan. Thank you. So that's what's happening because it's about the ends, it's about the highest exponents. The highest exponents dominate, right? They're both going towards 5. They're both going toward. So the graph themselves, if you look at the graph again, it's getting closer to 5. It's below 5, but it's getting closer to 5. Yeah, when x is negative, what's y doing? No, it's staying flat. This graph is flattening out towards 5.
Because look how it's going
It's
down. 5 on that.
It's getting closer to 5.
Oh, that one's just going up towards 5.
Right. So if you think about it, look at what's the highest exponent. If you always more political reference, 5x cubed is Trump. That's Mitch McConnell. Who's louder? Trump's much louder than Mitch McConnell, right? This would be say Nancy Pelosi. This would be like Gavin Newsom. After someone else. But Pelosi's much louder than Newsom. I don't know. Okay. All right, we'll stop.
This is like communist angles. Communist angles. Or,
So helpful.
I should teach AP Gov. Yeah. Actually, I loved Gov in high school. I really loved Gov. No, I just like politics is just interesting to talk about. I'm first of all these guys. Yeah. Okay. Guys, this is a little bit reversed. This is reversed because of negative x. You have x cubed or negative x squared. That reduces negative x, so it gets reversed. So if you plug in a positive number, it's negative. Negative number is positive. So just know that gets reversed. Okay, one last thing, and I'm all done. I love how we brought politics in our last lesson. Okay, but even more so today. All right. Okay, guys, again, highest exponents. What's the highest exponent here, guys? We're almost done. Let's finish strong. That's 5x. And what's the highest down below? Just x, right? This is 5x and x squared. That's 5x cubed and x. What does this reduce to? 5. What does that reduce to?
X squared.
5 over x. What was the last one reduced to, guys?
5x squared. -3.
5x squared. I'm only comparing the highest. Guys, I'm comparing the highest exponents.
The 5x.
Okay, it's okay. That was the Trump error. It's okay. Yeah, I'm not a fan of Trump, as you can tell. Anyway, anyhow, as x gets larger, y goes towards 5 in each of those cases for G. For H, now this is a tricky one. When x gets larger, you're doing 5 over a large number. What happens when the top is 5 and the bottom is large? What do you think that's going to get closer to?
0.
Good, 0.
Hold that.
That'd be 0. Because when the top is higher than the bottom, when the bottom's higher than the top, the bottom's increasing more quickly than the top ever would.
Oh, wait, that was right.
And lastly,
Look at
that's
that.
just going to be infinity.
What do you think?
Well, yeah, that's what I'm asking. What you do, okay, guys, just to recap, all of this is comparing the highest exponents and reducing. After I reduce, plug in a large number for x. We'll get away from the politics of my confused guys. That's fine. Just you reduce and you just see what it's going towards. So that 5x over x is 5. So regardless of what I plug in for x, okay, just think about it. If I plug in 1,000, what's 5,000 minus 3? 4997. What's 4997 divided by 1,000? That's pretty close to 5, right? So here, if I plug in 1,000 squared, that's a million. 5,000 or a million is still 0. Close to 0. And this just increases forever. And because it's squared, compared to putting a positive or negative, it always comes out positive and negative. So that's all I wanted to say about this lesson. You'll have a chance to practice it. Homework, cross off 4 and 5, guys. Cross off 4 and 5. 6, 7 are fair game, as well as 1, 2, 3. Okay. And I think that is it. Okay. So you guys have about 10 more minutes. You guys, I forgot to put the schedule on the board, but okay. AP or next, yeah. So you guys use this class to work on the review guide. You can do homework, whatever you guys need to do. This is the only one. Yeah, the rest of the packet. Yeah. Fix the quiz. Oh, you already submit them? I'll do it later in the week. Because I mean I can do it now if you want to. Sure. Just school just you submit homeworks. I'll do it now. I'll do it now. I'll do it now, guys. All right. How this? I'll do it daily in the afternoons. I'll update them daily in the afternoons as you. Which one? Okay. Sure.